So since you're in the third row, it's going to be 3. We're in the S block, so it's 3s1. After 3s1, we're here in magnesium, 3s2. That gets us to Mg. After 3s2, we come over here. This is called the P block. We're still in the third row, so it's 3p1, 3p2, 3p3, 3p4, 3p5, 3p6. For potassium then, we come down to a new row. So what number we got to use if we're in the fourth row? You betcha, you got to use a 4. You're in the S block. All of these end in S1, so this is 4s1. Now something I might ask you is I might ask you how many valence electrons. Valence electrons are the number of outer shell electrons. Now, how many shells do we have? We have 1, 2, 3, and 4 shells. These are shells, the numbers, not the orbitals, but the numbers. Your outermost shell is 4. How many electrons are in that 4th shell? 1. So this has 1 valence electron. Valence just means outer. Okay? All right, the next one on your list is titanium, Ti. Now look where Ti is. Ti is in a new block. S block, P block. Well, what letter was next in the orbitals that you drew? Well, the D block. You guessed it, all these end in D. Well, I wonder what this one is. Well, this would be D1, this would be D2, this would be D3, D4, D5, D6, D7, D8, D9, D10. So let's draw or write the electron configuration for scandium using our periodic table as a guide, because you will always have this. So we're going to end up here at Ti, but we're going to start up there at hydrogen. So let's use our periodic table as like a road map. So we start up here. So that's 1s1. Helium then would be 1s2. After 1s2, you come down to a new row. It's in the S block, 2s1, 2s2. That gets you to beryllium. You come across, this is the P block, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. That gets you to neon. Come down to a new row, new number. So this will be a 3. This will be 3s1 and 3s2. How many valence electrons do we have? The answer should be 2. But let's keep going because we got to get to here. After 3s2, we're back in the P block. We're still in the third row. So 3p1, 2, 3, 4, 3p5, 3p6. Now let's pause there and think about this for a second. How many electrons do I have on the screen right now? Well, some kids would say 6, and that'd be incorrect. My outermost shell is 3. I have 6 here, and I have 2 here. So I actually have 8 valence electrons on the board right now, or on the screen. But we're not done. 3p6 gets us to argon. So we come down to a new row. This is 4s1, 4s2. And that gets you to calcium. Well, I told you this is a D block, and you would think it's 4D, but it's not. The Ds are 1 energy level behind. There's a reason for that. We'll get into that later, but just for now, just believe me, these are 1 energy level behind. So instead of being 4D, this is going to be 3D. Just deal with it. This is 3D1. Titanium then would be 3D2. And that would be the electron configuration for titanium. How many valence electrons do we have? A lot of you are thinking 2, but it's not. Your outermost shell is 4. How many electrons do we have in this 4th energy level? We have 2. So this has 2 valence electrons. This is going to be important later when we talk about chemical bonding. Okay. What I want you to do now is I want you to pause the video, and I want you to write the electron configuration for chromium and for copper. And after you get those done, come back to me and we'll take a look and see how you did.